Hello everyone. So I welcome you all to this MSQ series. I know that you guys are having some wonderful sessions with other faculties, and I think this is the last session in MSQ, but it is very important because I will be covering all the thermodynamics questions. An MSQ series is important because this is the most confusing type of questions, because there are more than one answers, okay, and sometimes you are just okay, you maybe one answer you can get it right, but the second one you just get confused, okay, and sometimes there is trick as well. So practicing these questions are very important, and I hope that you all had wonderful sessions with all the faculties of BYJU'S exam prep in this series, okay. And today we are going to focus on multiple select questions on thermodynamics, okay. All the good questions I have selected for, I have designed some from myself. I have taken some gate questions, so I have designed a wonderful collection of questions for you, okay. Now so let us move on, and we are coming up with ESC previous year questions, and it has already started. It will start from tomorrow, 18th of August, okay. And we will be coming up with questions from year 2021, 22 and 23. I will be taking basic and applied thermodynamics, so there will be separate sessions, and very soon you will get the schedule for all the subject in ESC. And practicing ESC questions, this is what I recommend to my students as well, when I teach in like free batches and paid batches, that once you are done with gate questions, so when you study a topic, go revise your gate questions first. Do some 2 or 3 or 4 questions of gate, then solve ESC questions, because gate questions gives you some idea of the level of gate questions, okay. And ESC questions can help you build confidence. ESC 1 mark question is equivalent to gate 1 mark question, so it is a very good motivation booster for you, and solving these questions will give you so much motivation, okay. So try to solve these ESC questions. I will be taking thermodynamics, basic and applied, okay. So I hope that, are you able to, is my audio and video clear to you? I hope it is clear. Can you let me know now? So we are starting it from 18th. My session will be 22nd of August, but you will be getting the whole schedule very soon on the Telegram group. So what you can do, you can join the Telegram group. I will very soon give you the link as well, okay. Also, ISRO batch is going on, guys. If you are focusing on ISRO exam, then this is the best batch that you can get. It's the crash course. We are working on conceptual revision, formula revision and practice questions, okay. So please attend these courses on YouTube. Make an Excel file, write all the sessions that you want to attend, write that down the time as well, okay. And make sure you attend these sessions, because if you are targeting ISRO, then you have to attend. You cannot miss, okay. We come up with new questions. We come up with previous year questions as well, okay, to have a balance between both, okay. Now, is it buffering, Ramakant? I don't think I can see it is going good. I mean, I have, like I can see it on YouTube, so I don't see any buffering. Can you recheck? Can you just, reload your browser? Okay, chalo. So, how do you know all these sessions? Join these Telegram groups. So it is mechanical general group. You can scan this QR code and directly go to the Telegram channel, and you see 4,000 people like you. 4,000 people like you are part of this group. So build this community we have built for you. Take advantage of this community. Be a part. Like you have to, you have to friends with people who have the same goal. So these 4,000 people have the same goal as yours, okay. So be the part of this community. Ask questions, ask doubts, And basically here you will get all the information about us. Even we are connected there. You can ask directly doubt from there. Or if you want to connect with me, you can connect with this Telegram group. Directly scan this QR code, and here a lot of people ask doubt, ask guidance for other exams, GATE, ESC, AE, JE, and all the other exams. So join these groups. It is the main mode of communication between you and us. And not just that, it is the community that is important. So many people are working just like you. So you need to have that feeling that I need to do something better than these people. Okay, if you are just preparing yourself, hello, Papa ka listen. Okay, so if you are just doing it alone, then you would never know what is your level of preparation. You need to be the part of that community. Okay, so that you need to know where you are, where do you stand in comparison with other people. So that's why join these groups, take active participation in question solving, take active participation in doubts sessions, go to free app classes. Okay, so I regular have free app classes, so you can join those free app classes as well. Okay, chalo. So this is my brief introduction. Guys, please share the session quickly. We will be solving very good questions, MSQ questions. So join this session and share this session as soon as possible, as quickly as possible. Okay, so I have around 6+ years of teaching experience. I have done my MTech from IIT Kharagpur. I have done my MS from Politecnico di Milano, and I have around 3.5 years of teaching and industry experience. My area of expertise is basic and applied thermodynamics and heat transfer. This is all I think you all know. I don't have to tell you. Yes? So let's start the session. And I think few questions will be there which we already solved because I took this session, but due to some technical issue, we were not able to continue. So few questions will be same. Chalo. Let's move on. I cannot stop anyone. Okay. Chalo. Also, if you are really serious about your preparation, and the only constraint that you have is financial constraint to take part in this scholarship test, get up to 90% of a scholarship. So it is happening on 28th of August. You can take it any time during the day. Okay. So up from 10 to, yes, I am just starting, Ashwin. Next slide is questions only. Okay. So you can get up to 90% of scholarship. Okay. Chalo. Okay. Let's go ahead. Let's start. Okay. Chalo. Few questions maybe you have seen already because I have already taken this session. So I will not solve them. You have to solve them. Quickly tell me. So you have to tell magnitude of heat interaction and the direction of heat interaction. Quickly, guys, quickly. The working fluid in a thermodynamic engine cycle undergoes work and heat transfer as given. So you have this cycle, and work and heat interaction is happening. So two work interaction. One is work input is equals to 15 kilojoule and work is 44. Work output is it is zoom only, right? It is the highest width. Okay, maybe you can zoom it in your mobile or something, but it is in the whole PPT. Okay, chalo. Now they are saying 3 heat interaction is happening, 2 are given. So first heat interaction is Q in is equals to 75 and second is Q out is equals to 40 kilojoule. Third one I don't know. Third one I need to find out. So that is what I need to find out, magnitude and heat interaction. I need to find out magnitude and heat interaction. What is the magnitude? What is the heat interaction of Q3? Let us say Q3 is this. Q3 is this. Ashwin, that is correct. I think that is correct. Yes. And what is it? To the fluid or from the fluid? Okay. To the fluid or from the fluid? So this is your heat engine. Work input is 15. Work output is 44. Q in is 75. Q out is 40. I need to find out Q3. To the fluid. Are you sure? Are you sure? But to the fluid or from the fluid? Is it given to the cycle or rejected from the cycle? So you can do first law of thermodynamics for a cycle. So summation of Q is equals to summation of W. Summation of Q is equals to summation of W. Okay, just 1 second, guys, just 1 second. Okay. Yes, it is from the fluid. Ashwin, you were wrong. Okay. Chalo, let's see how is it getting. So Q in is positive. Q out is negative. This is also out. This will also be negative. Work in is positive. This will be negative. So it is 75 minus 40 minus Q3 is equals to my work input is negative. I am sorry. Input is negative. This is positive. So minus 15 plus 44. So Q3 is equals to 75 minus 40 plus 15 minus 44. So now how much you are getting? How much you will get? 75 minus 40 plus 15 minus 44. So you are getting plus 6 kilojoule. Now here what does plus mean? Plus does not mean that it is transferred to fluid. What does it mean? It means that you have assumed the correct dimension. Because already minus we have given here, already minus we have put here. So now if it is coming positive, we have already considered a direction. So if we are getting positive, it means that we have considered the right direction. We have considered the right direction. So that is correct. Magnitude is 6 and from the fluid. Okay. Chalo. Next question. Quickly. Very simple question. I think you have already seen this question. A spring-loaded piston cylinder device contains 5 kg of helium. So we have this cylinder we have this cylinder which has piston and a spring is attached. Okay, it contains 5 kg of helium. Now the system is heated from this pressure. So P1 is equals to how much? 100 kilopascal. P1 is 100 kilopascal and T1 is 20 degrees Celsius. 20 means 293 Kelvin. And then P2 is equals to 800 kilopascal and T2 is equals to 160 degrees Celsius. So 160 is how much? 160 is 433 Kelvin. Determine the heat and work interaction. Both we need to find out, heat and work. Yes? Ashwin, are you solving this? Now you see, from if I draw PV diagram, I need volume as well. Okay, what I can do, I can find out volume from here. V1 is equals to mRT1 upon P1. So M is known, R is known. It is what? It is helium. So R is given, T1 is given, P1 is given. Okay, so 2 into 2.08 into 293 by 100. How much is volume? How much is volume? V1. Quickly. How much is V1, guys? V2 also you can calculate. M R T2 P2 to this 433 upon 800. How much is V1 and V2? Quickly. How much is P1 and V1 and V2? Come on, quickly. V1 is? Are you solving this or not? Yes or no? I mean, if you are solving it, then I should stop. Otherwise, I will write the answer. So, V1 you are going to get how much? 30.47 meter cube and this is 5.621 meter cube. Why are you getting 12, Baba? 12 is what? Okay, this is 5 kg. I'm sorry, this is 5 kg. Okay, I just misread it to 2. It is 5. Okay, I just thought it is 2. Chalo. Now what do we know? Look, P1 we know, V1 we know. So I can mark P1 100 and V1 30. P1 is equals to 100, V1 is equals to 30.5 meter cube. Also I can write P2 is equals to 800 and this is 5. Now you see, I know point 1, I know point 2, and if I know the process, I know that area under the curve gives us work transfer. So what kind of process will be there? What kind of process will be there? Quickly guys, what kind of process? What kind of process is there? It is when there is spring, then when there is spring, there is always linear relationship. There is always linear. No, it is piston cylinder, right? It is not open. It is closed. But what kind of process is happening? Whenever you see, because it will only allow to go up very slowly. So it is a linear relationship. So basically, spring is, whenever spring is there, you can draw this diagram between 1 and 2. Okay, so you are going like this. So if this is my curve, why I am drawing this curve? Because of spring, linear relationship between pressure and volume. So pressure is equals to AV plus B. Some kind of relationship is there. Okay. Why this linear? Because of spring. Okay. So now I have drawn this process and I know that area under this curve will give me work interaction. This is work transfer, dW. So now you can calculate dW by dW for this area, for this whole area is how much? Half P1 plus P2 and V2 minus V1. So half, or basically V1 minus V2. Final minus initial, okay. Final minus initial. Final is, sorry, V2 minus V1. I'm sorry. Final minus initial. Final is 2, initial is 1. Now P1 is 800, P1 is 100, P2 is 800. So total is 900. Now V2 was 5.6 something and this is 30 point something. This is 5.6 to 30.47. So tell me how much work you are getting. How much work you are getting? Sadi Carnot. I am not the right person to answer this. Okay, soil mechanics is, I think, civil subject, right? So it's better if you ask a civil faculty, he will be able to advise you better. If you want answer, you can ask something from mechanical engineering branches. I can answer that, okay. But as I can see, that is civil engineering, right? Soil mechanics is from civil, isn't it? Chalo. dW you have gotten 112. How do you get this? You will get minus 11182. 11182 basically. Kilojoule. Are you getting this? Are you also getting this or not? Now they are asking calculate heat transfer as well. So dQ for a closed system, du plus dW, and du is what? M CV T2 minus T1 minus 11182. Mass is 5. CV is given. CV is 3.12. 3.12. T2 is how much? T2 is 433. This is 293. So 433 minus 293 minus this. So how much are you getting? Now what is the heat transfer? Minus 8998 kilojoule. So you are giving it is work input and this is heat out. Heat out. Heat out. Okay? Clear? Good? Did you get it? Guys, come on, Ashwin and Papa ka pagle son. Whoever is there, try to solve it with me, because when will you solve? Tell me. When will you get extra time to solve it? Nowhere. If you're just sitting down and watching this lecture, then you are doing a mistake. You are anyway giving that this much time, right? So solve before me, give the answer. If you are hesitating, writing your answer in the comment, look, online is the best way to come out, okay? So for example, if there is a physical class, maybe sometimes you feel embarrassed, I have done wrong, maybe I have done wrong, I should not answer. But what is the, hesitation in answering in this? You can directly answer in the comment box. Nobody knows you. You are just growing yourself by solving questions, and by writing it, you have a sense of, satisfaction inside. Trust me, when you answer it, you have a sense of satisfaction inside. Okay? Chalo. So yes, that is correct. That is correct. Solid mechanics. Okay. Solid mechanics you said. I read it. Soil mechanics. Okay. So MS in solid mechanics or applied mechanics. Applied mechanics is also Madras. So what you can do is, I'll tell you the best thing. If you are in the Telegram group which I shared in the beginning, you can connect with me. You can directly text me, and I will connect you with one person who is in IIT Madras. Okay, so he knows much better about placements. He knows much better about the actual status of the branches. Okay, so I think that applied mechanics is better in MS. Okay, so he is in aerospace basically. Okay, but he knows better. He knows because when I was in IIT Kharagpur, I knew what are the placements of other branches as well. Okay, and he has done BTech in mechanical, so he knows about these things. Okay, so he can give you a better idea, but I think that applied mechanics is better. But in terms of placement, I am not very sure. That is my perception. Okay, chalo. Let's move on to the third question. Again, very easy question, guys. Quickly, what do I need to find out? Net work transfer for the cycle and net heat transfer for process 1. I have to check which options are correct. So basically, I have a cycle in which 3 processes are happening. Pressure, volume. Process 1 to 2 is constant pressure. So 1 to 2 is constant pressure. So this is P1 is equals to P2 1.4 bar, and V1 is given 0.028. I don't know V2, but what I know is work output is happening 10.5 kilojoule. The next is 2 to 3 is compression with isothermal. PV is equals to constant. So something like this you are getting. Okay, now here it is PV is equals to constant. So 1 to 2 and 2 to 3. So when it is constant, that means T2 is equals to T3 and U3 is equals to U2. This is what is given. This is what it is given. Okay. Then 321 is constant volume. 321. That means V1 is equals to V3. And they are saying that here U1 minus U3 is equals to minus 26.4 kilojoule. 26.4 kilojoule. This is given. This is given. So what can you do? What can you do? Now let us take process 1 to 2. 1 to 2. Okay. Now they have given work transfer is equals to 10.5. Work 1 to 2 is equals to 10.5 kilojoule. Okay. And what is the work in constant pressure process? What is the work in constant pressure process, guys? How do you calculate work in constant pressure process? Quickly. What is the formula to calculate constant pressure process work transfer? Everyone should participate. Come on, guys. Everyone should participate. Do not hesitate. How do you calculate? Come on. This you must know, yaar. Come on. If you do not know this, then you have to first go and revise your concept. That is very important. What is the heat? What is the work transfer for constant pressure process? Come on. Really? You don't know or you are not commenting? Please, come on, guys. Open up. Chalo. It is pressure and dV, which is V2 minus V1. Yes. So 10.5. What is the pressure? It is 1.4 bar. That means 1.4 into 10 to the power 2. V2 I don't know. V1 is 0.028. 0.028. So from here you can find out your V2. You can find out your V2. How much is V2? How much is V2? Come on, guys. V2. Quickly, fast. So V2 is 0.103 meter cube. Okay. Now let me go to this process 2 to 3. 2 to 3. So process 2 to 3, work 2 to 3, it is what? Isothermal. Isothermal. So do you know how to calculate isothermal work transfer? 0.0123. No, that is not correct. Okay. So how do you calculate work? Guys, really look. If you are not writing, that is also okay. But if you do not remember these formulas, then it is time that you revise your formulas. I am telling you seriously, 6 months are left for GATE. You need to revise your formulas. It is very important. And you should have a revision cycle. Okay? You do not just revise today and forget it for 2 months. There must be a revision cycle. Okay, so if you are learning a concept today, revise it in 1 or 2 days, then revise it within a week, then revise it within a month. So you need to have a revision cycle. Okay, so what is work transfer in isothermal? By P2 V2 minus P3 V3 upon no, that is not for isothermal. I am really sorry. This is a polytropic. So this is P2 V2 ln V2 by V3 by V2. V3 by V2. Now you know V3. Yes, you know V3, you know V2 also. Okay, and you know P2 V2 as well. So you know P2 V2, you know V3 and V2. You can directly put. Yes, you can directly put. Quickly guys, P2 is how much? P1 is equals to P2, so it is 1.4 into 10 to the power 2. V2 is how much? We have just calculated. ln V3 is equals to V1, 0.028. This is 0.103. How much you are getting? 2 to 3 work transfer. How much work transfer you are getting? Come on. If you are just viewing this session as a Netflix or Amazon Prime or your Avatar movie or something, then guys, I am sorry, it is not going to help you anyway. You need to have a paper, you need to have a pen, you need to have a copy, you need to have a calculator. Solve these questions with me, otherwise there is no use of these sessions. Tomorrow you are not going to remember any formula, anything. So you are getting minus 18.78 kilojoule. Yes? Is it that? Seriously? No, that is correct. That is 0.103, not 0.0103. Okay? Chalo. So now next is process 321, which is constant volume. And what is the work for constant volume, guys? You should know this. This is the must know thing if you are studying thermodynamics. Work 321 is equals to how much? Constant volume work, constant volume work, constant volume work. Constant volume work is na baba, na Siraj. That is open system work. Closed system work is always PdV. Now because volume is constant, so dV is 0. So closed volume work is 0. This is the most basic thing we should know. Yes, PdV is there, but it is 0 because change in volume will be 0. Volume is constant, change in volume is 0. Okay, so what is the net work? W122 plus W223 plus W321. So this is 10.5 minus 18.78 plus 0. How much is net work? Net work is minus 8.25 kilojoule. This is net work. So let's see what are the option asking. Net work for the cycle is this. Is it correct? Is it correct? Or D is correct? Which one is correct? A or D, which one is correct? D is correct. Yeah, I mean approximately minus 7 is also okay. Approximately 8 point something you are getting. Okay. Now what about heat transfer? Heat transfer I need to find out. So when I talk about heat transfer, I will use dq is equals to du plus dw. Yes, D is correct. Yes, D is correct. Okay. So when I say process 1 to 2, so that means dq 1 to 2 plus u is equals to u2 minus u1 plus dw 1 to 2. Okay. Now how do I calculate u2 minus u1? So now see, they have given u1 minus u3 is this, and this is also given u3 is equals to u2. So can I write u1 minus u2 is equals to this? So can I write u2 minus u1 is equals to 26.4 kilojoule? Yes. Yes or no? Yes, I can write. So that I can write here. So dq for 1 to 2 is equals to 26.4, and work is already given. You see, this is work 10.5 plus 10.5. So dq of 1 to 2 is equals to 26, 36, around 37. Around 37 you are getting. 36.9 kilojoule. Yes. What about process 2 to 3? Again dq 2 to 3 is equals to u3 minus u2 plus dw 2 to 3. Now you see, u3 is equals to u2, isothermal process. u3 is equals to u2. So yes, that is correct. 36.9 is correct. Okay. That means this is 0. u3 is equals to u2. So dq 23 is equals to dw23. And what is the isothermal work 23? Minus 18.78. Minus 18.78 kilojoule. What about process 3 to 1? By dq 3 to 1 is equals to u1 minus u3 plus dw 3 to 1. Just now I told you 3 to 1 will be 0. Always write with sign. Okay. Okay. Always give me a short name. Okay. I can't just say all whole name again and again. But you always write with sign, because you need to have this habit of writing sign. Otherwise, most of the time you will get your question answer wrong. You have solved it correctly, but while marking you will mark it wrong. Okay, money, yes, money. Okay, so dq 3 to 1 is equals to u1 minus u3. So what is u1 minus u3 is this, minus 26.4 kilojoule. So what is dq net? dq 1 to 2 plus dq 2 to 3 plus dq 3 to 1. 36.9 minus 18.78 minus 26.4. How much is it? Same, minus 8.28 kilojoule Q net. Okay, so let's see the option. Tell me which options are correct. D is correct, I know. A is wrong, I know. What about B and C? What about B and C? Which one is correct? Which one is correct? B or C? Or both? It is multiple select. More than one option can be correct. Give me the option. Which option is correct? Which option is correct? C is correct. And you have got your question wrong. Net heat transfer, where is minus? Where is minus, Baba? In the option, have they given you minus? Carefully see the question. Carefully see the option. C is not correct. B is correct. Yes. Everyone who is watching this, please write in the comment box, guys. Please write in comment box. Okay. So C is not correct. B is correct. Because unless you do these mistakes, you will not understand the importance of things. Okay. So solve the question. Write your answer. Do it wrong. I would say even if you are doing it wrong, it's fine. But write your answer so that I can tell you what you can do to correct it. Okay, chalo. Next question. A piston cylinder device initially contains you have a piston cylinder device and it initially contains M1 is equals to 0.6 kg of air with volume 0.1 meter cube of volume. यही प्रीत, डरना नहीं है. Whatever fear you have, however scared you are, you need to get up in the morning. You need to, first of all, you need to plan your next day in the night. You need to get up in the morning and follow that plan. Solve questions. Keep going. Look, if you are scared, it's okay. Everyone is scared. But if you stop, then your fear will become your reality. So you do not have to stop. Look, maybe you will not get successful. Maybe you will not get a good rank. But I guarantee you one thing, that if you stop today, then for sure you will not get a good rank. If you keep going, there is 1% possibility maybe you will get a good rank, but there is a possibility. But if you stop, then there is not a chance that you will get a good rank. So yeah, money. This is an unusual request I have gotten. I have never gotten this request because the same proportion is there every time. But I don't know. Maybe you are seeing it in a mobile screen or something. Okay. So I think it's the same thing that every time I use. But I will see. I will see what we can do to this. Okay. Chalo. Anyway. So breathe. You don't have to stop. You have to promise that yourself. Okay. Never stop. Because anyway, even if you give everything for 5-6 months, but you will not be achieve anything, you will not lose anything. Because I know in next 5 months you are not going to achieve anything big anyway. But if you work, if you give these 5 months, maybe there is a 1% chance you will be able to do something. Whatever, if you stop today, whatever you want to do after stopping, you can do after February as well. Okay, but right now, do not. Whatever fear is there, fear is normal. But don't let that fear stop you. Get up in the morning, go ahead with your preparation. That is all. Okay? That is you have to motivate yourself every day. Motivation comes, it's not natural, you have to motivate yourself. Whoever says it comes naturally, they are, I would not say they are wrong, but it is not true entirely. Okay? Chalo. The mass of piston is such that it maintains constant pressure. Pressure P1 is equals to P2 is equals to 800 kilopascal. Now the system is connected to a valve. The system is connected to a valve where supply is, so P in is equals to 5. This is the unsteady flow question. Ti is equals to 500 degrees Celsius. Volume of the air doubles when air flows in. volume becomes V2. So it expands and volume becomes 0.2 meter cube. And temperature T2 reaches 250 degrees Celsius. I need to find out the mass of the air entered. So mass of the air entered will be equal to final mass minus initial mass. Okay. 1 M1. M1 I know. Am I able to find out M2? So M2, by look, M2 will be equal to P2V2RT2. Okay. So P2 is how much? Same. 800. V2 is how much? 0.2. R is 0.285. T2 is 250 plus 273. 250 plus 273. 523. 5. How much is M2? Tell me. How much M2 you are getting? So this is just 6 months hard work, beta. I mean, you can live your life whenever you want, but this hard work is always hard. That is why it is called hard work. Okay, hard work. So it is only for 6 months. Adjust, do whatever you can. Okay. So what is M2? What is M2, guys? M2. M2 is how much? Preet. Money. How much is M2? 1.066 kg. Okay. So Mi is equals to 1.066 minus 0.6. M1 is 0.6. So that much mass has entered. So how much is it? It is 0.466 kg. So mass entered is this. What about heat transfer? What about heat transfer? Not just 1.066. Okay. Always try to write your answer till 2 decimal place. At least 2 decimal place. Yes. Now I need to find out heat transfer as well. So for that I can use steady unsteady flow energy equation. So Mi Hi plus Q in is equals to control volume work plus M2U2 minus M1U1. What is Mi? M inlet. M inlet is 0.46 into Cp 1.005 into Ti. So Ti is how much? It is 500 degrees Celsius. 500 means what? 773, right? 773. So 773 plus this I need to calculate. Control volume work means constant pressure work. Pressure remains constant. So P V2 minus V1. Pressure is how much? 800. It is 0.2, 0.1. M2 is, just now we have calculated 1.066, 0.718, and T2 is 523 minus this is 0.6. 0.718. What about T2? What about T1? Sorry, T1. I don't know T1. I can find out. How? So T1 will be equal to, by PV is equals to MRT. So T1 is equals to P1 V1 upon MR. M1 basically. Okay, so P1 is 800, V1 is this, M1 is 0.6, R is 0.285. What is T1? What is T1 quickly? T1 is 464.5. So you can put it here. 464.5. So only unknown is this Q in. You can find out how much Q in you are getting. How much Q in you are getting. Q in. Come on guys, how much Q in? Q in. No, Preet, what is that? 0.5455. No, Q in is not that. That is MI. That is MI. That is true. Okay. So write what you are answering. Okay. So what is Q in? Are you calculating, guys? Are you calculating Q in? Tell me quickly what is Q in. Did you calculate? So Q in is, come on Mani, Preet, come on guys, whatever is there, be the part of the class, okay, be the part of the class, come on. It is minus 81.8 kilojoule. That means heat is rejected. Heat is rejected. So mass transfer is minus heat transfer is minus 81.8. Minus 81.8. Yeah, 80.8 is also correct. Okay. Basically, you got the nearest answer. Okay. 81.8 is the correct answer. Basically, like maybe some calculation mistake you have done, but you are very close. You are very close. Okay. Chalo. Let's move on to the next question. A Carnot heat pump. We have a Carnot heat pump. Working between 5 degrees Celsius. So 5 is how much? 278 Kelvin and 60. So 60 is I think 433. And it is driven by a Carnot heat engine. So it is driven by a Carnot heat engine. This is also Carnot heat pump. And this heat engine is working between 840 degrees Celsius. So 840 is how much? 840 plus 273. It is 11 and 60. That means 433 Kelvin. The engine also runs a machine that requires 30 kilowatt. So basically, whatever work output you are getting, some 30 kilowatt is going outside and rest of it is work input to the heat pump. Now the heat pump extract. So let us say this is T1, this is T2, this is Q1, this is Q2, this is Q3, Q4, T4, T3. Now the heat pump extract 17 kilojoule per second from 5 degrees Celsius reservoir. So I need to find out heat supplied to engine. That means I need to find out this. And I need to find out total heat rejected to 60. Total heat rejected. So at 60, this is also 60, this is also 60. So I need to find out Q2 plus Q4. These are the two things I need to find out. Yes? These are the two things I need to find out. Okay? Chalo. So how can we start? You see, these are both are Carnot. So what I can do is efficiency of reversible heat engine is equals to 1 minus T2 by T1 is equals to work maximum by Q1. Okay, or let me say work output here. Work output. Okay, so this is 1 minus 433 upon 1113 is equals to work output upon Q1. So how much is efficiency? How much is efficiency? It is 0.7. No, it is, I think, okay, my mistake. This is 333. Okay, so this will be 333. So this is 0.7 is equals to work output by Q1. So work output is equals to 0.7 Q1. Okay, because both are unknown. Now I can't move forward, so I need to do something else. What can I do? I can go to this. Okay, yes. So COP of reversible heat pump is equals to T higher or T4, let us say. T4 upon T4 minus T3 is equals to Q4 by work input. Yes. Now what is Q4? So you can say by this energy balance that Q3 is equals to Q4 plus W in. So Q4 is equals to Q3 minus W in. So I can write T4 is 333 by 333 minus 278 is equals to Q3 minus Wi by Wi. Now how much is Q3? Q3 is 17. Yes? 17 is given? Yes? So now only unknown will be Wi. So you can calculate Wi from here. How much is Wi? What is Wi? Wi is this, okay? So how much is Wi? How much is Wi? W in is 3.36 kilojoule. Right? Now from here I know that W out is equals to 30 plus W in. W in I have just calculated 3.36. So W output is equals to 33.36 kilojoule. Okay, 33.36. So now I know W output. I can put W output here, and I can calculate Q1 is equals to 33.36 by 0.7, and Q1 you will get 47.66 kilowatt. 47.66 kilowatt. Yes, 33 is correct. Very good. So the first thing they were asking, Q1. So heat supplied is around 48. Around 48. Yes, we got 47.66. That means B is correct. B is correct. Now total heat, यानी कि Q2 and Q4 I need to calculate. Q2 and Q4 I need to calculate. So Q4 तो I can calculate here itself by Q4 is equals to 17 minus 3.36 by this is what? W in, right? So Q4 is equals to how much? By 17 minus 3.36, it is 13.64 kilojoule. Yes? What about Q2? By now I know this. Q1 is equals to 48. I know W output as well. So I can calculate by I know Q1 is equals to W output plus Q2. So Q2 is equals to Q1 minus W output. So 48 minus 33.66. So Q2 is how much? 14.3 kilowatt. So now I can calculate Q2 plus Q4 is equals to 14.3 plus 13.64. The answer is 34.66 kilowatt. Yes? Okay, Q4 is basically no, one second. This was wrong. By energy in will be equal to energy right? So Q4 is going out. It will be equal to Wi plus Q3. Okay. So the same thing you are going to write there. So it will be 17 plus Wi. 17 plus Wi. Okay. 17 plus Wi. I am sorry, that was by fault. Okay. So now work input is 3.36 plus Q3 is 17. So it will be 20.36. So this is 20 point. गलती हो जाता है भैया. 20.36. Now you will get D. Okay. Good. Chalo, let's move on to the next question. Very simple question. A heat engine working between, so now I have a heat engine. These type of questions are frequently asked. It is working between 1000 Kelvin and 300 Kelvin. Now it is driving a heat pump. It is driving a heat pump that absorbs heat from T3 is equals to 300 Kelvin at the rate twice at which engine rejects heat to it. So Q3 is equals to 2 times of Q2. The efficiency of engine is equals to 0.4 times of reversible, and COP of heat pump is equals to 50% of reversible heat pump. The rate of heat supplied to heat engine, that means this is given as 50 kilowatt. So I need to find out T4 and heat rejected to heat pump. Heat rejected by heat pump, and high temperature. This is both I need to find out. So T4 and Q4 I need to find out. So it is based on the similar concept we did in the last question. Will you be able to do it? It's very simple. You see, efficiency of engine is equals to 40% of reversible heat engine. So what is reversible heat engine efficiency? 1 minus T2 by T1. It is 0.4. 1 minus 300 by 1000. So it is 0.7 into 0.7. So your actual efficiency is how much? 0.28. Actual efficiency. And this is also equal to work output upon Q in. So work output will be equal to 0.28 into Q in. So 0.28 into Q in is how much? 50. Yes, 50 is given, right? So W output is how much? 14 kilowatt. So now I know this as well. I know this is 14 kilowatt. So Q2 is how much? 50 minus 14. So it is 36 kilowatt. Now what is Q3? 2 times of 36, that means 72 kilowatt. Now what is Q4? See how simple is it? Q4 is 72 plus 14. 72, 82, 86 kilowatt. Any doubt in this? Simple energy balance. Okay. Now the point is how to calculate T4. So T4 I can calculate by using this equation. So COP of actual heat pump is equals to 50% of COP of maximum or reversible heat pump. So this is how much? This is Q4 by work is equals to 0.5 T4 by T4 minus T3. Now Q4 is 86. Work is how much? 14 is equals to 0.5 T4 minus T3. T3 also I know. T3 is 300. So the only unknown is T4 here. How much is T4, guys? Quickly tell me how much is T4. How much is T4? Quickly. T4 is how much? Are you guys solving it? Yes or no? If you are solving, then I will wait. How much is T4, guys? Come on. I'll give you 30 more seconds and then I'll give you the answer. If you are solving it, if you have solved it, kindly tell. Please give me the answer in the comment box. Quickly. What is T4? Money. Preet. So T4 that you will get is 326.5 Kelvin. Is it what everyone is getting? Is it what everyone is getting? So 327 is the correct answer and heat rejected is 86 kilowatt. ANCR correct. ANCR correct. Okay. Chalo. Let's move on to the next question. A reversible heat engine operating between T1 and T. Okay. So basically I have this engine. It is operating at T1 and intermediate temperature T. Now the energy that is rejected Q2 from this engine is received by another engine. So same Q2 is given by another engine. Engine 1, engine 2. Okay. At the same temperature. And it is rejected, let us say Q3, it is rejected at Q2. Rejected at Q2. Which options are correct? Which options are correct? So for this, we have to, once we have to keep the work. So it is W1, it is W2. So if W1 is equals to W2, then what is the relation? What is T? And if efficiency 1 is equals to efficiency 2, same cycle efficiency, then what is T? In terms of T1 and T2, this we need to find out. Okay, chalo. So let us first take when efficiency 1 is equals to efficiency 2. And we know it is reversible heat engine. Okay, they have told us reversible heat engine. So for a reversible heat engine, I can say 1 minus lower temperature, that means T, higher temperature, that means T1. Yes. What about N2? It is 1 minus lower temperature, that is T2, and higher temperature, that is T. Yes. So for this is the lower temperature 1 and this is the higher temperature. For this second heat engine, this is lower temperature, this is higher temperature. Okay. So because efficiency of a reversible heat engine is basically 1 minus T lower by T higher. Okay, so this and this I can cancel. T square is equals to T1 into T2. That means T is equals to under root T1 into T2. This is my intermediate temperature. So that means for the same cycle efficiency, T is arithmetic mean? No. T is geometric mean of T1. So D is correct. D is correct. What about work transfer? When the work is same. So let us see that as well. So when W1 is equals to W2. W1 is equals to W2. So what is the efficiency, Baba? 1 minus T lower by T higher. It is also equal to work upon Q in. So from here W can be said as Q1 1 minus lower by higher, and this is Q2 1 minus T2 by T. Yes, right? Now also for reversible cycles I know that Q1 by T1 is equals to Q2 by T. This we prove for reversible engines, right? Reversible cycles. So Q1 is equals to T1 by T into Q2. So let me substitute it here. T1 by T, Q2 1 minus T by T1 is equals to Q2. Are you guys able to understand it? Yes or no? Are you guys able to understand this? It's very simple. And this will get cancelled. This one T1 by T minus 1 is equals to 1 minus T2 by T. Okay. So what can I do? T1 by T plus T2 by T is equals to 1 plus 1. So T1 plus T2 by 2 is equals to T. So when work remains same, intermediate temperature is the arithmetic mean of T1 and T2. Arithmetic mean of T1 and T2. Okay. So when work transfer is same, for the same amount of work transfer, geometric mean no. It is arithmetic mean. Same amount of work transfer, T is the arithmetic mean. So C and D are correct answer. C and D, they are correct. Clear? Yes? Yes or no? Chalo. Let's move on to the 8th question. 10 questions are there. Total 10 questions are there. Okay. Now a reversible engine draws 5 megajoule. So basically I have this engine. Okay. And it is reversible heat engine. It draws 5 megajoule from, let us say, T1 is equals to 400 Kelvin. Q1 is equals to this. And it also does work output is equals to 840 kilojoule. Now it also involved heat interaction from 300 and 200 Kelvin. It also involves heat interaction. So basically there is one more thermal reservoir, let us say 300 Kelvin, and another reservoir T3 200 Kelvin. So it is interacting heat with this as well. So let us say it is taking heat Q2 and rejecting heat Q3 from this. So now I need to tell what is the magnitude and direction of Q2 and Q3. What is the magnitude and direction of Q2 and Q3? Okay. So the first thing that I will do is energy balance. Okay. which is first law of thermodynamics for a cycle. What is that? Summation of Q is equals to summation of W. So let us say Q1 by Q1 plus Q2 minus Q3 is equals to work output. Q1 is 5, Q2 I don't know, Q3 I don't know, this is 840, right? Okay, this is megajoule, this is megajoule, this is kilojoule. So I have to write 5000. This is 5000. So Q2 minus Q3 will be how much? Q2 minus Q3 will be how much? It is minus 4160. Okay. So now one equation, two unknown. So now I will go to my entropy concept of Clausius inequality. For a reversible cycle, it is equals to 0. That means Q1 by T1 plus Q2 by T2 minus Q3 by T3 is equals to 0. Okay. So now I can find out Q2. I can get one more equation. So what is that equation? Q1 is 5000 and temperature is 400 plus Q2, T2 is 300. Okay, wait. Let us take this as T2, this as T3, because this is also Q3, this is also Q2. Okay. So T2 is equals to 200 minus Q3 by 300 is equals to 0. Now I get one more equation. What is that equation? Q2 minus Q3 is equals to how much? So this is 4 by 6 is equals to minus 15,000. Minus 15,000. Okay. This is what you are getting. Okay. I think this is what you will get, because you will get the denominator as okay, anyway, this is what you should get. This is what you should get. 4Q2 minus 6Q3 is equals to minus 15,000. Minus 15,000. Okay. So now you have two equations, two unknowns. So Q2 minus Q3 is equals to minus 4160. And you have, what do you have? 4Q3 minus 6Q3 is equals to minus 15,000. So now you can solve it. Two equations, two unknown. Okay. So now Q2, how much Q2 you are going to get? Q2 you will get so let me multiply it by 4. I have solved it differently, that's why I am not sure about the answer. 4Q2 minus 4Q3 is equals to, I have to multiply this by also 4, and this is minus 16640. So now I can do minus plus plus. This will get cancelled. Minus 4Q3 plus 6Q3 is equals to minus 16640 plus 15,000, it is minus 1640. So this is 2Q3 is equals to this, and you will get Q3 is equals to 8 minus 820 kilojoule, minus 820 kilojoule. Okay, now I can write Q3 in this equation. So I will get Q2 plus 820 is equals to minus 1460, and I will get minus Q2 is equals to minus 4980, minus 4980. So what is saying? That this heat, the direction is opposite. Direction is opposite. That means Q3, what we have taken? Q3 we have taken going out, but it means it is heat input. This we have taken, again direction is opposite. So we have taken it going in. So that means it is heat output. Heat output. So Q2 is basically 200 Kelvin. So 200 Kelvin is rejected. So this is true, and is given is this. This is true. Okay, clear? Good evening, Sandy. Okay, so this is the right options. Chalo, let us move on to second last question for today. Let us move on to second last question for today. Chalo, a resistor of 30 ohms. So basically I have this resistor, okay, 30 ohms is maintained at constant temperature of 27 degrees Celsius while a current passes to this. So resistance is 30 ohms. Current is 10 ampere. Temperature is kept as 27 degrees Celsius. And the time is equals to 1 second. Which of the following options are correct? Entropy change for the resistor and entropy change for universe. So you have to understand, if resistor is your system, then so if I let us say resistor. So if resistor is my system, is there any heat transfer involved with the system? So it should be dq by temperature of resistor. But is there any heat transfer involved with the resistor? No, only electrical work. So this is electrical work, I square RT. I square RT is the electrical work that is involved. Yes or no? That means 10 square into 30 into 1, 3000 joule electrical work is involved, no heat transfer. So Q is 0, this means system is 0. What about surrounding? dq by T of surrounding. Now you see, for surrounding, what is happening? This heat that is generated because of the current that is flowing in the resistor, that is added to the surrounding. So heat is added to the surrounding. So this whole electrical work is converted into dq for surrounding, only for surrounding. Okay, so this is 3000 by 27 means 300. That means 10 kilojoule per Kelvin is the surrounding. So Baba, what about universe? So entropy change for resistor is 0. But what about universe? Entropy change of system plus entropy change of surrounding. That means 0 plus 10, and it is plus 10 kilojoule per Kelvin. So you have to always remember that entropy change for the universe is always positive. Entropy change for universe is always positive. So this is increase in entropy principle. Always greater than equal to 0. Always greater than equal to. Do you know this? Yes? Do you know this or not? Chalo. Let us come to the last question for today. Question number 10. All were good questions I have selected especially for you. Okay? Because MSQ practice is very important. A lot of time I can see here people are confused. 90% of the students remain confused. They do wrong in MSQ questions because the options are very tricky in MSQs. Okay, so you need to practice more and more MSQ questions. Okay, chalo. Now we have a turbine. Air expands in a turbine adiabatically from this. So what do we have? We have this turbine. It is entering from here. It is leaving from here. So when air is entering, the pressure P1 is equals to 500 kilopascal. Temperature is 400 Kelvin and velocity is 150 meter per second. Now when it is going out, pressure P2 is equals to 100 kilopascal. T2 is equals to 300 Kelvin and V2 is equals to 70 meter per second. Surrounding environment is at 17 degrees Celsius, that means 290 Kelvin, and P naught is 100 kilopascal. Now when per kg of air, that means when mass is equals to 1 kg, calculate available energy and irreversibility. I need to find out. Available energy and irreversibility I need to find out. Yes? Do you know what we are going to do? Available energy and irreversibility. So it is an open system, you see. It is an open system. So available energy is equals to phi1 minus phi2. So what is this? What is phi? H plus v square by 2 minus T naught S. So I can write H1 minus H2 plus V1 square minus V2 square by 2 multiplied by M plus T naught S1 minus S2. So, I can write M Cp T1 minus T2 plus M V1 square minus V2 square by 2 plus T naught or M T naught Cp ln T1 by T2 minus R ln P1 by T2. Now mass is 1. They have given mass is 1. Okay. So what can I do? 1.005 this is my T1, this is my T2. So T1 minus T2 is 100 plus mass is 1. This is my V1, this is my V2. So 150 square minus 70 square by 2000, because everything I am taking in kilojoule. Okay, plus T naught atmospheric is 290, 1.005 ln. T1 is 400, this is 300 minus 0.285 ln. This is P1, this is P2. So 5, I will get 500 minus 100 by 5. Now, very important point to understand here, that this is your maximum work that you can obtain from this condition. So you see, you have this condition. When you keep expanding it till the atmospheric conditions, so that is maximum work. But actually you are not doing it. You are only expanding till this point. So basically here, this is your actual work. And this whole thing is your maximum work. Okay. So your maximum work is equals to how much? How much are you getting? Are you solving this? So this is 109.3. Okay, one second. I have written it correctly here, but here I did mistake. It is minus here. Okay, it is minus. So minus, minus and minus. Okay. So minus how much are you getting? How much are you getting? Quickly take 1 minute and solve this. Tell me the value. So this whole thing, are you solving this? What is that you are getting? So, thank you, Yash. So you are going to get how much? Are you solving this? So the overall thing, you are going to get minus, you will get 159, okay, 159.47, and this quantity actual is basically 109 point something, 109 point something, I don't know. Okay, so they are asking, this is your available energy, this is your available energy, it is the maximum energy that you can obtain when you go from this condition to atmospheric condition, but that is not what you are doing. You are only going till here. So irreversibility is always maximum work that you can obtain if you go to atmospheric conditions minus actual that you are getting. So maximum is 159, actual is 109. So you see, this is maximum, this is actual. The ratio, the difference is around 15. So this much work is getting lost because of irreversible losses. Okay, clear? Guys, give me a thumbs up if it is clear. Quickly. Chalo. So this was the last question for today's session, and as you all know that we keep coming up with Sunday ka Funda, good funny, fun sessions, and Super Saturday too. Basically, we know, as Preet was also saying, as we also know that you people, because you are in your preparation phase, so you have to go to a lot of stress. Okay, sometimes you get bored, sometimes you get frustrated. So we keep bringing up these sessions to bring some excitement in your monotonous life. Okay, so we do some experiments, we bring up something, and this Sunday I am also bringing up with a concept of understanding the concept of thermal conductivity and thermal diffusivity by using a coffee cup. Okay, so every Sunday some faculty will bring you something. Also on Saturdays we launch some new things. Okay, something general that will basically excite you into this journey. Okay, so keep watching these sessions, join the Telegram groups. So involved in the process completely. If you have decided to prepare for GATE, involve in the process completely. Okay, give everything what is required for next 6 months, and then do whatever you want. Okay, so I hope that you enjoy today's session. I am going to stop here. Thank you very much. Okay, I'll see you in the next session. Bye bye.